Welcome to the quadratic function series. In this video, we shall understand the discriminant and its role in predicting the nature of roots in the quadratic equation. Consider a general quadratic equation where a is 2, b is -3, and c is -4. As this quadratic expression cannot be factorized, we apply the quadratic formula to obtain the x solutions. In the previous video, we saw that the quadratic formula when applied gives the general solution to any quadratic equation. Therefore, it follows to wonder, is there a part of the quadratic formula that determines the nature of the x solutions? What are the corresponding implications? To answer these questions, let us take a closer look at the quadratic formula. Zoom into the part of the formula where we have plus minus square root of b squared minus 4ac. Depending on what values this part of the formula evaluates to be, we can get different number of x solutions. In fact, to simplify the analysis, let us look at the expression under the square root sign. Let us label that expression as d, where d equals b squared minus 4ac. We shall call d the discriminant in the quadratic formula. Let us look at the cases for the discriminant d. Consider the equation 2x squared minus 3x minus 4 equals to 0. Calculating the discriminant as -3 all squared minus 4 times 2 times -4, we have d equals 41. Here we have case 1, where the discriminant is positive. This means that the quadratic formula has the value 41 under the square root and produces two different solutions for x. The function will cut the x-axis at 2 points. We say that the solutions to this equation, x equals -0.851 and x equals 2.35, are real and distinct. Furthermore, we see that the function y equals 2x squared minus 3x minus 4 is 0 at the two x-intercept values, is positive for some x values, and negative for other x values. Next, consider the equation 2x squared minus 4x plus 2 equals to 0. Calculating the discriminant as -4 all squared minus 4 times 2 times 2. Here we have case 2, where the discriminant is 0. In this case, the quadratic formula has the value 0 under the square root sign and produces only one unique value for x. The function will touch the x-axis at one point at x is equal to 1. We say that the solutions to this equation are real and equal. Sometimes the solutions are also referred to as repeated roots, x equals to 1. Furthermore, we see that the function y equals 2x squared minus 4x plus 2 is 0 at x equals to 1 and positive for all other values of x. Now, consider an equation 2x squared minus 4x plus 3 equals to 0. Calculating the discriminant as -4 all squared minus 4 times 2 times 3, we have d equals -8. Here we have case 3, where the discriminant is negative. In this case, the quadratic formula has a negative value under the square root. Since the square root of a negative number does not produce a real value, there is no real solutions for x. Graphically, the function will be entirely above the x-axis. There is no x-intercepts at all. We say that the solutions to this equation are not real. The solutions are imaginary or complex. We also see that the function y equals 2x squared minus 4x plus 3 is positive for all values of x. It is noteworthy to highlight that for some quadratic equations with negative x squared coefficients, such as the case shown above, the discriminant may be negative. When the coefficient of the x squared term is negative and the discriminant is also negative, there is no real solutions to the equation. The function is negative for all values of x. In ending, here is a flowchart showing the three discriminant cases and the corresponding nature of x solutions to the quadratic equation. As with many labels in mathematics, labels have meaning. b squared minus 4ac is called the discriminant because it has the role in telling apart the nature of the roots in a quadratic equation. In terms of quadratic functions, the discriminant also plays the role of predicting the number of x-intercepts as well as the range of y values for that function contingent on a, the coefficient of the x squared term. I hope you have learned something from this lesson. See you in the next video.